Hello guys, this particular segment of the video is purely targeted at people with roles like technology managers and integration practice lead. Without going too much into the detail, I will be just showing this entire thing in action, where a developer, after making the code change, checks it in the source code repository. Here, because it's TFS, a build agent will pick up the changes and create a NuGet package and then push the package to Octopus server. Octopus server, once it has identified there has been a change in the release for a package, it will create or trigger a release in an automated fashion, and the life cycle would ensure that the new release is automatically deployed to a runtime box. The life cycle could be configured in such a way that it just deploys automatically for, say, dev phase onto the dev box, but for other phases it doesn't automatically deploy. So that can be configured on Octopus. So now we'll see this in action. So let me just go to my VM. Let's just quickly have a look. So here the queue at the moment does exist. Just quickly delete this queue. So what I'm doing here is deleting the application from the existing runtime box, so it doesn't exist, and we can see it all being nicely created. Let's just quickly delete these artifacts. So the queue, we just deleted the queue. The application, so we just deleted the application, so it shouldn't be there anymore. Let's just quickly delete the workload management policy as well. Let's just delete other artifacts like user defined configuration service, a monitoring profile, so now the server is blank. It doesn't have any trace of that application. What I will do now, as I will act as a developer and make a code change. So let me just take the code and just update the long description. So there is a code change. Now the developer goes ahead and checks in the change. This is just a plugin error, we can ignore it. So now the code has been checked in. Now a new build is just in progress, and it was just scheduled just now. So the build definition in TFS automatically picked up the code change. It's running its steps, and at the end, okay, the build is successful, and it should have updated package in the library. So let's have a look. Okay, the test app now is at 1:00:26. That was just created now for 3:59:04, which is very close. So it was just created now. Let's have a look at the project, the real build project. So this build project actually goes ahead and deploys the application onto the runtime server. So a release was automatically created, and the release is automatically set to be deployed onto the runtime box. So it's executing steps one by one. Hopefully this shouldn't take that long. This particular step usually takes a bit longer because it's cleaning the entire application, even if the application is very small. It's cleaning the application and its resources, its artifacts, and creating a bar. The other steps usually run within seconds, so we'll just wait for this one. Yeah, so this particular step has finished. It has moved on to the next step. So now we see here that all the steps have executed, and at the end we have created an Octopus artifact. So post this release is fully successfully deployed onto a runtime box. It has created an artifact. This artifact becomes the source of truth. Like once it goes into production, we can always restore our application with an artifact that was actually published. So now let's have a look what has actually happened on the runtime box. So in the just few seconds ago, few minutes ago, we ensured that we removed the trace of that application. The application didn't exist. Now we see that application has been deployed and it's there. Let's just have a look at the resources. Workload management policy called high load is created and is available. A workload management policy allows application to be nicely managed from a workload perspective, so you can ensure that your flows do have enough threads to execute, or they can execute at a particular rate, and also like if they are doing any database transactions, can they commit their database transactions in a particular interval. So that's all about workload management policy. It can be shared across applications. Then let's have a look at the monitoring profile. Now we have created a monitoring profile. Of course, it doesn't mean much when you look at this in this way, but it allows an application to emit events at runtime. So we can have monitoring profiles specifying that when a flow is running at in runtime, and what we can log what came in and what went out, so it becomes easier for the BAU team to support the application in production. So that's the monitoring profile. Multiple applications can share the same monitoring profile file. Now let's look at the user-defined configuration service. The user-defined configuration service is basically a key value pair. It can be shared across applications. So if you want your applications to be really dynamic, then you have objects like UDCS, where an application code, once it is deployed and you want to make some configuration changes, you just update the UDCS, and once this object is updated, next time the flow runs, it just picks up the new values, and your flow doesn't have to be deployed. It's just a configuration change, and that can help the applications to be really dynamic. So we saw monitoring profile being created, UDCS object being created, workload management policy being created. Let's have a look whether the queue was created. So we deleted the queue. Now just have a look whether the queue does exist. Yes, the queue now exists. And also let's see what's my message flow looking like. So the message flow, as you see, we have applied the monitoring profile to the message flow, and this would ensure that the monitoring is now also active. So this would ensure that the BAU can support the application at runtime, BAU team can support the application at runtime as relevant events would be monitored, and also a workload management policy is applied to the flow, and this would ensure that the flow is nicely managed and given number of threads to execute at runtime, and other non-functional requirement properties are also set for that particular flow. So now this is seeing that entirely in action, where we just saw a developer checking in the code, the build agent picking it up, pushing it onto Octopus server, and Octopus server actually deploying the application onto the runtime box. The ways you can use Octopus tentacles, I'm using Octopus tentacle in a remote way where the tentacle can be shared across different boxes, and it depends on the licensing preference. You can have a tentacle per box, and it just makes it easier, but it depends. If you have Octopus server or other products, they typically have licensing from an agent point of view, which actually goes ahead and builds and automates and deploys applications. So that's what I wanted to show in this particular segment of the video. Hope you liked it, and if you're interested, I would be sharing in detail which would be more appropriate for an audience of type developers and the guys who really like to know what is going underneath, and how to configure artifacts in different places, like what's the build definition here, what's the build project here, and things like that. Thank you very much for watching this video. If you're interested further, do let me know. Thank you. Bye.